This presentation provides an overview of Chapter 9a in the book titled Simple G, a gridded economic approach to analysis of sustainability of the Earth's land and water resources, edited by Iman Hakiki and Thomas Hurdle, and published by Springer. This chapter focuses on the validation of the Simple G model, using the Simple G Brazil model as an example. Simple G Brazil is the region-specific model that focuses on agriculture, land use, and the environment in Brazil. More details of this model and the validation procedure are available in Chapter 9 of this book. This slide provides an overview of all chapters in the Simple G book, each of which has an accompanying presentation to motivate the material covered in that chapter. During this presentation, I'll cover a portion of Chapter 9, which is on model validation, comparing gridded and regional simulations to observations. Previous chapters laid the groundwork by providing theoretical foundations, introducing general conditions, specifying mathematical equations, discussing the gridded data and parameters, and computer implementations. In this chapter, we'll focus on validation of the model. After the development of this model and database, the next milestone was model validation. Here, we hindcasted Simple G Brazil from its 2017 baseline to 2000, using socioeconomic shocks, and compared the simulated national crop output and cropland area with observed data from FAO Stat. As are shown in the figures, Brazil has experienced continuous growth in both crop production and cropland expansion, so we expect the model hindcasting from 2017 to 2000 to show reductions in crop output and cropland area as we move backwards in time. When we evaluated the initial version of Simple G Brazil, we found that although simulation results are consistent with observed data on the reduction pattern of crop output and cropland, the model underestimated the magnitude of reduction, in particular for cropland area. So what caused the mismatch between simulation results and observations? We took a stepwise strategy to check different dimensions of the model. In the first step, we set the change of Brazil's crop output to be exogenous and equal to the observed change, and checked the similarities between simulated and observed cropland area. This approach allowed us to isolate the production system from the trade and demand system. We found that with the observed change in crop output, the model can replicate the change in cropland, which indicates that the supply system is valid. We concluded that the likely reason for the mismatch was from final demand or the trade system. In Simple G, crop output is used to satisfy three categories of crop demand: the exogenous demand for biofuels, the endogenous demand by domestic consumers, and the endogenous demand from global markets. In the second step, we checked the baseline data of biofuel demand and found that in the initial model, we calculated biofuel demand based on an outdated data source, which underestimated the change of biofuel in hindcasting. To fix this problem, we updated the data source of biofuel demand and conducted the validation again. Now, the simulated crop output and cropland area became closer to the observed data, but the model still underestimated the percentage change in cropland by half. In the third step, we further examined impacts from the endogenous demand side. We compared simulation results with the crop supply data for domestic use and export from the GTAP database, and found the model mainly underestimates the reduction in export. This finding indicates that some factors from the global market caused the mismatch in validation. To control impacts of those factors, we further set the change of world crop price to be exogenous and equal to the change of World Grain Price Index from the World Bank over this historical period. Although the model with exogenous world price overestimated the reduction of both crop output and cropland, the relative pattern on domestic use and export matches GTAP data much better. To resolve the problem of being over-responsive to the world price, we adjusted the elasticity of substitution and transformation in the Armington trade function. After validation and calibration, the simulated results on both crop output and cropland became much closer to observations. Here, we summarize the validation results from each step. The takeaway message of the Simple G Brazil validation is that when the mismatch exists, a useful strategy is to separate different systems by setting key variables exogenous in order to identify the source of the problem, and then proceed in a stepwise fashion. In this case, we needed to update both the data and the model parameters to obtain a satisfactory match of simulated and observed data for Brazil over the 2000 to 2017 period. On this slide, you'll find the link to the SimpleG webpage where you can find additional resources, as well as links to the book and other chapter presentations. Lastly, we also gratefully acknowledge support from the U.S. Department of Energy, the Department of Agriculture, and the National Science Foundation. Thank you for watching this presentation on the SimpleG book, Chapter 9a. We encourage you to explore the other companion videos that accompany the book on the SimpleG webpage.